So dear student, we are going to discuss question number 6.12. Clear? In this question it is given to you a square loop of side 12 cm with its side parallel to x and y axis is moved with the velocity 8 cm per second in a positive x direction. Clear? So first of all, let's suppose if I am drawing here, let's suppose I am saying this is z axis. I am taking this direction as z axis. Clear? This one is what? This is y axis and this one is x axis. Let's suppose. Clear? Now here it is also given to you. Actually, sides of this square lies parallel to x and y axis. It means I can say this square loop is lie in xy plane. Clear to you? So let's suppose this one. Clear? It is also given this loop is moving with a velocity of 8 cm per second in positive x direction. So I can say velocity is in this direction and value of velocity is given 8 cm per second. So I can convert it into meter per second. So this one is meter per second. Clear? Yes. Now we can say side of this square loop is given. It means we can also find here area. Clear? What about area? Area is given by 12 into 12 into I can say 10 to the power minus 4 meter square. Clear? Okay. Actually it is moving in a positive x direction in an environment containing a magnetic field in positive z direction. Clear? So I can say magnetic field is acting in this direction. So magnetic field in this direction, that is B. Clear? Yes, magnetic field is acting in this direction along positive z direction. Fine. And it is also given the field is neither uniform in space or nor constant in time. It means I can say value of magnetic field, this is changing with respect to x as well as with respect to time. Clear? It means I can say value of magnetic field is changing with respect to x as well as with respect to t. Clear to everyone? So it is given in a question. It means I can say this magnetic field is a non-uniform magnetic field. Clear? Now it is given it has a gradient of 10 to the power minus 3 Tesla per centimeter along negative x direction. It means I can say dB by dx, this is given to you 10 to the power minus 3 Tesla per second. So 10 to the power minus 3 Tesla per centimeter. Centimeter means you can convert into meter, 10 to the power minus 2 meter. Clear? So from here we can say this is equal to 10 to the power minus 1 Tesla per meter. Clear? Okay. Now we can say it is also given to you here. It has a gradient of this one along negative x direction and it also decreases with time with 10 to the power minus 3 Tesla per second. Clear? So we can write like this, dB by dt. Clear? dB by dt, this is equal to 10 to the power minus 3 Tesla per second. Clear? Now we have to determine direction and magnitude of induced current in the loop. Clear? If resistance is 4.50 milliohm. Clear? It means this is equal to 4.5 into 10 to the power minus 3 ohm. Clear? Now you can say, sir, why this induced EMF will be produced? Induced EMF will be produced because value of magnetic field is changing with space and time. Clear? Now we are going to discuss first value of that induced EMF. Clear? So listen carefully. Now we can say induced EMF. First of all, we are finding this induced EMF due to changing of magnetic field in space. Clear? So I can say E1, this is given by, we can say that is d phi by dt. Yes or no? d phi by dt. We are just finding here magnitude. Clear? So d phi by dt means we can say this is d by dt and multiplied with dm. Clear? Now you know cross section area. Area is same. So I can say this is equal to A dB by dt. Clear? Actually here we are finding induced EMF with respect to space. Clear? So with respect to space means we can also write it like this. This is dB by dx dot dx by dt. Clear? Now we know dx by dt. Dx by dt equal to what? This is velocity. Clear? So A V, I can say this is dB by dx. Clear? A V, this is dB by dx. Clear? This is value of E1. Clear? So from here if we put here value of A, V and dB by dx, A is given to you. Yes. Value of A we have, that is 12 into 12. clear, 12 into 12 into 10 to the power minus 4 multiplied. What about velocity? Clear, velocity, what about velocity? Velocity is given to you, this is 8 into 10 to the power minus 2, clear. So 8 into 10 to the power minus 2, and what about dB by dx? dB by dx, you know, this is 10 to the power minus 1, so 10 to the power minus 1, clear. So from here we can write like this is equal to 144 into 8 into 10 to the power minus 4, and here we have minus 3, so 10 to the power minus 7, clear. So we can also write like this is 1.44 into 8 into 10 to the power minus 5, clear. So if we multiply it with 8, we can say this is, we have 32, so we have 3, we can say this is 35, and this one, so 11.52 into 10 to the power minus 5, clear. So we can say this is in volt, clear. So I can say this is induced EMF due to change in magnetic field with space, clear. Now we can also write like this, induced EMF, we can say induced EMF due to change in magnetic field with time, clear. So we can also write like this is equal to dB by dt, clear. Area is given to you 12 into 12 into 10 to the power minus 4 multiply. What about dB by dt, clear. So dB by dt, this is given to you 10 to the power minus 3 Tesla per second, clear to everyone. So 10 to the power minus 3, so we can say 144 into 10 to the power minus 7, clear. So if you convert in this form, I can say we can write like this 1.44, clear, 1.44 into 10 to the power minus 5 volt, clear. So this is value of induced EMF, clear. So from here we can say value of E, this is given by E1 plus E2. Now why I am adding here both induced EMF? Because you can see here, if we are talking about this magnetic field is decreasing with respect to position, and this is also decreasing with respect to time, clear. In both cases we can say magnetic field is decreasing, clear. So it means induced EMF will be produced like this, it will try to increase magnetic flux, clear. So finally I can say I can write like this, E equal to E1 plus E2, clear. And if I put here value of E1 plus E2, this is equal to 11.52 plus 1.44 and multiplied with 10 to the power minus 5, clear. So now if you add it, you can say this is 6, this one is 9, and this is 12.96 into 10 to the power minus 5 volt, clear. Now our objective in this question is to find induced current, clear. So induced current we can write like this is E by R. E is given 12.96 into 10 to the power minus 5 divided by, what about resistance, clear. Value of resistance is given 4.5 into 10 to the power minus 3, so 4.5 into 10 to the power minus 3. Now let's suppose if we find here approximate result, I can say this is 13, so 13 into 10 to the power minus 2 divided by, I can say this is 9 by 2, clear. So this is 9 by 2, clear. So from here we can say 26 by 9 into 10 to the power minus 2 ampere, clear. So now you can say this is near about 3, because 9 multiply 3 27, so we can say we are getting answer near about 3, clear. This that is 3 into 10 to the power minus 2 ampere, clear. So this is value of induced current, clear. So this is all about this question, clear.